right, our first step for solving this difficult problem, where does the block land? First, we need to find with what speed is it leaving this ramp. So when it leaves this ramp, how fast is it going? With what speed? We need to use our answer from yesterday. So I'm going to make up an answer for the acceleration from yesterday. That's the acceleration while it's going down the ramp. So we'll say the acceleration equals 2 meters per second squared. Okay. So because this is a constant acceleration, we can use our kinematic equations. So our kinematic equations, we got to think of this as a problem where we want to know the initial speed, and what we're really looking for is the final speed. What's the final velocity as it goes off of this ramp? So let's still choose this as our coordinate system, because we know what the acceleration is in our x direction if we choose this as the coordinate system. So in that coordinate system, what's happening in the x direction? Well, if it starts up here from rest and then we release it, we can say the initial velocity is 0. Now as it's moving down this slope, we calculated in yesterday's problem the acceleration is whatever you found it to be from yesterday. What else do we know? Well, we know the length. If we define, again, we're defining this as our positive x direction. So x is in this direction. Our length in that direction is 1 meter. And the last thing that what we're trying to find is what's the final speed as it leaves the ramp. So here I have 3 knowns and 1 unknown. I don't need to look in my y direction, because if you have 3 knowns, you can always find a 4th unknown. So look to your kinematic equations. Here's a different problem, but let's look to our kinematic equations and try to find which equation we need. So this is one of the equations that has all 4 variables in it. So let's look here. We want to know what our final velocity is. Our initial velocity is 0. Our acceleration is 2 meters per second squared. And delta x is 1 meter. Take the square root of both sides, and we get 2 meters per second. So this is the speed at which it leaves the table. The next part of it is we can visualize this as a separate problem. We want to look at this now as a problem where we have a projectile we know what the initial speed is that it's going. We just found that in our last part to be 2 meters per second. So this is 2 meters per second. And we also know with what direction it's going. So let's see if I can draw it over here to make it a little bit more clear. If we have, here's our table. Here's our ramp. If it leaves the table going this direction, if this was 45 degrees, we know this is also going to be 45 degrees. So we have a new problem. We've got an object that's under the influence of projectile motion moving with some initial speed. This is the direction. We know the height of the table. We want to find where does it land. Now let's look at our free body diagrams, how it changed from the first question to the second, or first part of the question to the second part of the question. Now, our free body diagram, as soon as it leaves that table, the only force acting on it is the force of gravity. There's no normal force pushing it up. There's no friction slowing it down in this direction. And if we ignore air resistance, the only force acting on it is gravity. So the acceleration is only going to be in the y direction because that's the only force acting on it. And it's going to be negative 9.8 meters per second squared. You can actually show this if you say F net y is equal to ma. The only force in the y direction or the x direction is the force of gravity. So force of gravity is ma. Now our definition for force of gravity is mass times gravity. Look what happens to our mass on both sides. Cancels. So our acceleration is 9.8. And we're going to say, if we make this our positive y direction and this our positive x direction for this new problem, your force of gravity is down. So this 9.8 becomes negative 9.8 if we make this our positive y direction. So let's try to solve this problem, this new projectile motion problem. Alright, so we'll need a little refresher with projectile motion, but here's the situation if you want to draw it on your paper. When we're doing projectile motion problems, the first thing we want to do is break up if we have an initial velocity, break it up into the x and y directions. So we've changed our coordinate system. So now that this is the positive y and this is the positive x direction. So because we changed it, so this is the positive y and positive x direction, now this is no longer your velocity, 2 meters per second, which before was just in our x direction, is now in a little bit of both the x and y directions. And again, the reason we did that is because my acceleration is straight down, whereas before my acceleration was on an angle. Okay, so let's find what those two components are, like the initial velocity. So we have 2 meters per second, 45 degrees, Vix, Viy. Okay. I'm going to go ahead and pause the video, but you should try to find what Vix and Viy are at this time. Okay, hopefully you've gone ahead and found what the initial velocities in both the x and y direction are. So our next thing is to see what information we have and what information we need in the x and y directions. So in the x direction, well, this is what we're looking for. We want to know where do we put this cushion so that our block will land on it. So that's what we're trying to find. Our acceleration in the x direction is 0. The only force acting on this, remember, is the force of gravity. So my acceleration in the x direction is 0. What else do we have? Vix, the initial velocity in the x direction, 1.41. And because it's 45 degrees, it's a special angle, we're going to get the same answer in the x and y directions. Anything else? Well, we've got acceleration in the y direction is, because of my coordinate system, I'm saying this is the positive y. I'm going to say acceleration is negative 9.8 meters per second squared. delta y. I measured this for you outside. It's going to be 4.9 meters. And this is from the second floor to the ground. Okay. I think this is all that we know. Now, we're trying to find this. But with our kinematic equations, we need to know 3 variables to find a fourth. So in the y direction, we have 1, 2, 3 variables. So remember, we can always find time in the y direction and then use that same time in the x direction. So let's try to find time in the y direction, and then we'll use that time to find where should we put this pillow for the block to land on. So we need an equation that has all 4 of these. Delta. This one does. Now, one thing that's really important to include is we started here and we're finishing at a height on the ground. So we start here and we finish here. So my delta y is actually negative because we're going down. So let's plug in our numbers. Right. Now you might recognize we've got a t squared t and some number. So if we can't factor this, we're going to have to use the quadratic equation. So I'll go ahead and do that. You want to put 0 on this side. I like putting this number first, so that's going to be 4.9 delta t squared plus so this is going to be my A value, this is going to be my B value, and this is going to be my C value. My quadratic equation, delta t is like our x. It's negative b plus or minus square root of b squared minus 4ac all over 2a. So I'll plug in your numbers and see what you get. So when I put these numbers in the calculator, I get 1.2 seconds. So now we're going to use that 1.2 seconds to look in our x direction to find what delta x is going to be. So in our x direction, we have, we're going to use the same formula. Delta x is equal to VIX delta t plus 1/2 AX delta t squared. So let's plug in our numbers. We're trying to find delta x. VIX for me is 1.41. You'll have a different number. Delta t we just found to be 1.2. And my acceleration in the x direction, because the only force actually on this is gravity down, my acceleration is 0 in the x direction. So I just find delta x, multiply those numbers, and you get 1.7 meters. So when we do this test, I'm going to put a pillow 1.7 meters away from the base in hopes that the block's going to land on it. You'll get a different number. I just made up some numbers for the initial velocity and the acceleration from the previous question. But yeah, that's all.